Hello, gentlemen. In the last video, we looked at the graph of the sine and cosine function. In this one, I want to look at the other trigonometric functions. We're gonna pay particular attention to the tangent and the secant functions, and then I'm going to ask you to do the same thing that we're going to do in this video for the cotangent and cosecant function. Okay, so let's get started and let's look at the tangent function. Okay, as we know, tangent is defined as sine over cosine. All right. Now we have to pay particular attention now where cosine is equal to 0. That's going to be important because we're going to have division by 0. We know that we're going to have a vertical asymptote here. All right. We're not going to be able to cancel this term out. So we're going to have some vertical asymptotes where cosine x is going to be equal to 0. So here's the cosine function. And we know cosine is going to be 0 at negative pi over 2, negative 3 pi over 2, pi over 2, 3 pi over 2, etc. all the way through. So at those locations, the tangent function is going to have some vertical asymptotes. Okay. Now, once we have the vertical asymptotes and we understand that, what we want to do is we want to see how does the tangent function behave as I approach these asymptotes from both the left and the right. And this is coming back to this idea of limit that we talked about earlier. Let's look at the limit as I approach x. X is equal to negative pi over 2. So I'm actually going to come in from this direction here. Okay. And I want to see what happens to this ratio. What happens to sine x over cosine x? Well, what you're going to see is you're going to see that the sine function is going to approach 1 because we know that sine is equal to 1. So this approaches 1 on the top. This approaches 0. This is a very small positive number. Okay. So if I did something like 1 divided by 0.00001, I'm going to get a larger and larger number. I'm going to get a bigger and bigger number. And this bottom, this cosine value, is going to get smaller and smaller. And so the ratio of 1 divided by a small positive number is going to approach infinity, like that. Okay, so I know as I'm coming in this way, I'm gonna come up and I'm gonna start to get closer and closer, and I'm gonna head off to infinity there. Okay, that's what this bit of information tells me. I also want to look at what happens when I approach. Let's look at what happens when we approach a negative pi over 2. Let's see what happens on the other side. So we're looking at in between our two asymptotes. So as sine approaches negative pi over 2, this is going to approach negative 1. Okay, because if you remember the sine function, we came down from here. This is the sine function, then we came up to, that should go through 0, and then we came down like that. Remember, sine function was just off that way. It was off by a different phase. So we know that the sine function is going to approach negative 1. And again, this is still a positive small number on the bottom because cosine, as you can see, is still positive right there. So this is still a positive number, small. It's very small. Okay. So just like I had before, up here, I had 1 divided by a small number. Now it's negative 1 divided by a really small number. And so that's going to go off to negative infinity. Okay. So over here, towards this one, I'm going to come in and I'm going to do something like that. Okay. I'm also going to make use of the fact that tangent of 0, which is sine over cosine, is equal to 0 because sine of 0 is 0. So we had 0 over 1. Okay. So let's put those pieces together for this middle part here. And if I do that, I get the following. There's tangent function between negative pi over 2 and pi over 2. Okay. Now we know that the tangent function, just like sine and cosine, it's a periodic function. And this type of behavior right here is going to happen repeatedly in between all the asymptotes. So I'm going to get something like that. There's my graph of tangent. Note that I have asymptotes at whenever cosine of x is equal to 0. Okay. Let's look at some characteristics. The domain is all real numbers except pi over 2 plus n pi, where n is an integer. Let me make a note of that. It's an integer. Okay. And so 3 pi over 2, 5 pi over 2, all etc., etc., those are going to be vertical asymptotes. The range is negative infinity, infinity, so there's no stipulation there. And the period is equal to pi. It's going to repeat itself every pi. Okay? So there's the tangent function. You can do the similar thing with the cotangent function, but understand with cotangent, we have cosine x over sine x. So things are moving. So when I ask you to do this at the end of the video, we're talking about vertical asymptotes when sine is equal to 0, okay? Which is 0, pi, 2 pi, etc. You're still going to want to take the limit as you approach the left and right of your vertical asymptotes like we did. So make sure you're doing that for cotangent on your own. Let's look at secant. The secant function, again, we're going to start with the cosine function. The secant function is 1 over cosine of x. So again, we're going to still have vertical asymptotes when cosine of x is equal to 0. Again, can't have division by 0. So if we put those in there. Now, again, we want to see what happens as we're approaching these vertical asymptotes. Well, this time I'm getting 1. This is similar to the one we did before. We get 1 divided by a small positive number, right? Because cosine of pi over 2 is approaching 0. It's approaching, it's always going to be a little bit positive. So this is going to go off to positive infinity. I want to see what happens when I approach this asymptote over here. The difference this time is I have positive 1 in the top, and cosine of x is still approaching 0, but it's still positive, okay? Because cosine's positive when I come in from the left here. I mean from the right, okay? So this time, instead of going to negative infinity, I'm actually going to go to positive infinity. All right, so I'm going to come in positive infinity, and I'm going to go up to positive infinity here. And the other important point I want to know is secant of 0 is simply equal to 1. So that point is on my graph. And so what I'm going to do is I'm going to get that right there. This purple is the secant function on that interval negative pi over 2 pi over 2. Okay, and what I'm going to see is whenever I want to draw a secant or my cosecant, I want to draw vertical asymptotes where the functions are equal to 0, and then I'm going to have sort of a parabola shape with the vertex of the parabola at the max or min of the sine or cosine function. So what the secant function is going to look like if I put the rest of it in is right there. And this point here would be negative pi 1. Okay. Let's look at some of the characteristics of the secant function. Domain is the exact same as tangent, all real numbers except pi over 2 plus m pi. Range, actually range here is wrong, let me fix that. It's going to be, let's do the range over down here. The range of this function is going to be from negative infinity to negative 1. That would be these down here, because that point right there is pi negative 1. In union with 1 to infinity. Okay, so there's my range. Not there, sorry. So everybody needs to understand there's no value between negative 1 and 1. Okay, there's no value in here because cosine is always between 0 and 1. And so if I have 1 over cosine x, this number here is always smaller than 1, greater than negative 1. So there's no way to get a value, say, like 0.5, like 0.5 or 1/2. Okay, so here is my domain, and my period again is actually, whoops, it's 2 pi. Okay, because I'm going to go through from here to here is 1 cycle, and that's 2 pi right there, like that. Okay, hopefully that makes sense to you guys. Here are the other 6 trigonometric functions. Here's a summary of all of them. You guys need to make sure that you understand them. We did this one here today. We did this one here. I want you guys to take a look at cotangent, and I want you to look at cosecant on your own. Okay. Do some practice. I want you to read section 4.6, examples 2, 3, 4. I want you to look at the cotangent and the cosecant graph. I want you to go through the same process we just went through. Here are some practice problems. Okay? Any questions, again, make sure you're emailing me. We'll get those squared away. But just to review, we looked at the tangent and the secant function. We had vertical asymptotes where the cosine function was equal to 0. We looked at the domain for both of those functions. The domain was all real numbers except for pi over 2 plus n pi, where n was an integer. And we saw that the period for tangent was pi, and the period for secant was 2 pi. And finally, we saw that the range for tangent was all reals, and the range for the secant function was negative infinity, -1, and 1 to infinity. Okay, make sure you understand that the readings have talk about some shifting and some period things. It's very similar to what we did for sines and cosines. Okay, have a good day, fellas.